Good morning, boys and girls. Today we are starting our topic 15, and our first lesson is 15-1, Describe Quadrilaterals. We're starting on page 585. Let's look at the solve and share at the top. Fold a piece of paper to make the fold lines as shown below. How many different quadrilaterals as you can using the fold lines and the edges of the square paper? Sketch each quadrilateral you find and describe it. The area of each small triangle on the paper represents a unit fraction. Write the unit fraction and then find what fraction of the whole square each of your quadrilaterals represents. So let's just take a look. That's a lot of words, so let's see what our hint is from our helper right here. You can look for relationships. What attributes of the quadrilaterals can help you identify each by name? So if we have this piece of paper and we were to fold it, for example, we see we have a square, right? And if I were to fold it in half and in half again, how many squares do I end up with? From that one square, when I fold it twice, half and half, I end up with 1, 2, 3, 4. So for the square, I end up with 4 parts to make the whole. And if it wanted me to represent a unit fraction, it says write the unit fraction, we know that they're talking about only one part of those 4 pieces. But let's say that we took that same piece of paper and I only divided it in half. And so when I divided it in half, I ended up with how many shapes if I took that same square and divided it only one time in half? I would have ended up with a rectangle, 2 of them. So 2 would be my denominator. And then how many would only one of these rectangles be for my unit fraction? It would be 1. So we could take our paper and fold it in different ways and represent those unit fractions based on how many of those shapes we came up with. Turn your paper over. So now we're going to look at what are some attributes of quadrilaterals. The Welcome to Florida sign is a quadrilateral. How can you describe quadrilaterals? Well, first of all, remember a polygon is a closed shape that has only straight sides. A quadrilateral is a polygon with 4 sides and 4 angles. So an angle is formed when 2 sides of a polygon meet. So we have an angle here, here, and here. That point where 2 sides meet is the vertex. Here is the vertex, 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 vertex. We have sides, there's 4 of them. And right here, when we have the perfect square at the top, we see that that's a right angle. It's actually 90-degree angle. Now, some quadrilaterals have some special names. There's a trapezoid. The trapezoid has exactly 1 pair of sides on lines that never cross. Exactly 1 pair of sides on lines that never cross. So if we look at this trapezoid, we can see that this line and this line, this pair, would always continue on and never touch one another. So let me show you. So if I put my rulers right here, as you can see with my rulers, if they extended on and on, they would never meet. As with the side lines, we can see that if we had the side lines, they would meet. So when they're talking about a pair of sides on lines that never cross, they're talking about these that are parallel to one another. They're never going to meet each other. Now here we have a parallelogram. I love saying that word. And a parallelogram is opposite sides are the same length and the opposite angles are the same size. So if I look at this line and I were to measure it at the top and I come down here to the bottom and measure the bottom line, they're each the same length. That same thing would be true for these side lines. So here I can measure this line on this side and come over here and measure, and they would be the same length. So the opposite sides, this is opposite, these are opposites, are the same length, and the opposite angles, this angle and this angle, that angle and that angle, they're the same size angle. Now when we look at a rectangle, we can see that we have 4 right angles or square corners. So we could make a perfect square right inside the corners of each of these. So a rectangle has 4 right angles. A parallelogram is not a rectangle because the sides are slanted and do not form a perfect square corner, so therefore it has no right angles. But a rectangle has 4 of these special right angles, and here's a symbol that we often see. It's like a little square being drawn right inside the angle itself. Now we have a rhombus. On a rhombus, all sides are the same length. Now a rhombus is a very special parallelogram. Notice that the rhombus is slightly angled, just like that parallelogram on the sides. So it's kind of like a square that's not up straight. And with this rhombus, all 4 of these sides are the same length. So if we were to measure them, we would see that all 4 of these sides are the same length. That makes it a rhombus. It's a special parallelogram. Now, a square has 4 right angles, just like that rectangle, and all sides are the same length. A square is a special parallelogram. So notice we have the rectangle is a special parallelogram, the rhombus is a special parallelogram, and the square is a special parallelogram. Because notice that the opposite sides are the same length and the opposite angles are the same size. Now, we're not going to do this bottom, so you can just go ahead and put a little X in it. And let's turn our paper to the next page. Now we're going to be referring back to this page because it's going to be helpful for you as we solve. Now here's another part that we need to learn, and these are convex polygons. All the angles point outward. So we can see when these 2 lines come together here, it's pointing outward, 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 outward. All of our angles are going to point outward. Now, these are called concave polygons, and that means that 1 or more angles point inward. Notice how these angles come toward the inside of our polygon. This makes a concave polygon. This one has 2 pairs of angles that come, 2 pairs of sides that form an angle that comes in toward the inside of the polygon. Therefore, it's concave. It's like it's coming in. So let's see how you're doing on your understanding. This figure is a rectangle, but it is not a square. Why is it not a square? Do you know why this one's not a square? If you said that all the sides are not the same length, you are absolutely correct. So all sides are not the same length. Notice that the top and the bottom, they're the same length to one another, but they are a different length from the side. Remember, a square, all 4 sides would have to be the same length. Number 2, draw 2 different quadrilaterals that are not rectangles, squares, or rhombuses. So I'm going to draw 2 quadrilaterals that are not rectangles, not squares, so it's not going to be a rectangle over here. Let me slide this over so you can see both of them. It's not going to be a square, and it's not going to be a rhombus. Which 2 would I be drawing? So we could draw a trapezoid, and we could draw a what? parallelogram. So notice that my lines will be slightly offset from one another so that the side angles are slightly slanted. Excellent. Now, in numbers 3 through 6, it says, write as many special names as possible for each quadrilateral. So for number 3, what is the only name that we could call this one? It is a parallelogram. So when you're looking at it, and I'm going to look carefully myself, make sure you're spelling it correctly, and notice how small I am writing, because parallelogram is such a long word. Now, number 4, what do we call this one? Well, number 4 is obviously a what? Well, it's a rectangle, and I'm going to write that one on the inside. But remember what we said over here? A rectangle is also a special parallelogram. So here I get to write this long word again, parallelogram. Now look at number 5. Now number 5 is a, let's look back over here. Which one is it? It's a rhombus. I'm going to write that right on the inside. And it is also a what? That's right, a parallelogram. Love that word. Love the way it sounds. And number 6. What's number 6? Well, boys and girls, obviously all the sides are the same length, so it's a square. But it is also meets the requirements of a rectangle, because look, it says 4 right angles. So we have a right angle here, 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 and here. We do have 4 right angles, which we can often refer to as a square corner. So all squares are also rectangles. And if it's a rectangle and if it's a square, it's also a, what's that? Parallelogram. And one more. Man, that square qualifies for a lot of different things. It is also a rhombus because all the side lengths are the same. All right, so let's look down toward the bottom at the independent practice. It says, write as many special names as possible for each quadrilateral. So remember quadrilateral, 4 sides. So this first one is a what? That's right, rectangle and parallelogram. Takes a while to write that long word. Well, what about this number 8? Let me see, it's got 1, 2, 3, it's got 4 sides, and it's got 1 pair of sides, this one and this one, that the lines will never cross. Now, you probably don't normally recognize this as this shape, but this is a trapezoid. And number 9. Number 9, we've got opposite sides that are the same length and opposite angles that are the same size. This one is a parallelogram. Now let's turn our page. So when we look at this, it says vocabulary. A rectangle with all sides the same length is a, that's right, it's a square. And a parallelogram with 4 right angles is a, yep, rectangle or square. Now, it did tell us to draw a picture to help. So when we came over here with a rectangle with sides all the same length, That's the picture of our square. And when we came over here, parallelogram with 4 right angles, since we have 2 different that qualify for it, let's go ahead and just draw them both. And that was not a very good straight line on my square. Let me try to fix that up a little bit. And that rectangle also, oh my goodness, that was sloppy. All right, number 13. I am a quadrilateral with opposite sides the same length. Which quadrilaterals could I be? Opposite sides the same length. What's the first one? Parallelogram. Opposite sides the same length. Well, let's see. A rectangle is a special parallelogram. So a rectangle. Let's see. Opposite sides the same length. Yep. Rhombus. And opposite sides the same length. Of course, a square. Remember, sometimes, boys and girls, problems can have more than one correct answer. All right, let's jump down to number 17. Want to solve that one first, and we'll see if we have time to go back up. But a square and a rhombus are shown at the right. Which attributes do these shapes always have in common? Select all that apply. Remember, when you see select all that apply, you're usually going to have more than one correct answer. First of all, it says they have in common the number of sides. Well, we know that's true because they both have 4 sides. This one says the side lengths are in common. Are these side lengths in common with one another? No. The angle measures, are the angles the same? No. Do they have right, both of them have right angles? Well, the square does, but not the rhombus. Let's check this one out. Number of angles. Well, this one has 4 and that one has 4. So yes, they have the same number of angles. Now, let's look back up at Model with Math. Sue bought a book for $12, 2 maps for $7 each, and a pack of postcards for $4. Use math you know, like bar diagrams, equations, or properties of operations to find Sue's total cost. So a book for 12, 2 maps for 7. Well, that means I've got 7 times 2 equals 14, right? And a pack of postcards for 4. So I've got 12, 14, and 4. And I'm just going to add these together. 4 plus 4 is 8 plus 2 is 10. Bring my 1, 1, 2, 3. How much was the total cost for Sue's purchases? It was $30. All right, boys and girls. Now, for your homework tonight, we're at 15-1. You're going to answer number 1, 2, 3, 4, 5. And then when you turn it over on the back, you're going to answer 6, 7, and 12. Boys and girls, I hope you enjoyed this lesson today with quadrilaterals, and I'll talk to you tomorrow. Bye.